Hi everybody, this is Mrs. Ellsworth. What we're going to be talking about today is about chemical reactions. So use your note sheet that was passed out and let's go ahead and get started on this. First of all, there are different parts to a chemical reaction. So if we would go and look at an example generic type of chemical reaction, we would take element A and add element B to it, and then we would get a compound of AB. Okay, this is just one type of reaction. This one is called a synthesis reaction, which we will be talking about the different classifications in a couple of days. So just looking at this right here, notice that this has got a yield sign. Oops, Y-I-E-L-D, a yield sign, and that there are some that's before the yield sign and some that are after the yield sign. The yield sign points in one direction, of course, and the ones that are prior to the arrow, are called reactants. The ones after the yield sign are the products. Now think about this. You have a chemical reaction, you're going to put some things together, you're going to put some chemicals together, they're reacting together. And then right here, this is what happens before, this is what happens after. And so your final product is what you want to have at the end, okay, created by this type of chemical reaction. Now, this whole thing is called a chemical equation, and it represents a chemical reaction. Again, this written right here is a chemical equation, just like this one, and it represents a chemical reaction. Remember we talked about how do you know if a chemical reaction has occurred? Whether it changes colors, the substances in your test tube, whether it creates gas or whether it bubbles, fizzes, creates gas, whether it creates a lot of heat or it gets cold. Those type of things are a chemical reaction, and we will display what's happening molecularly with a chemical equation. Okay, so some terms that you need to know: reactants, the yield sign, products. Okay, now there's another term that we're going to talk about here in just a moment called coefficients. Coefficients and also they tend to get confused with subscripts. But coefficients are the big ones that we put in front. I know that you probably remember from 9th grade science or physical science. But anyway, so coefficients are what we put in front of it. These are multipliers. Okay, they multiply everything. So like if we went and put a, let's see, let's look at this here. If we went and put a 2 in front of this one, that means that there's 2 aluminums, and then there's 2 times 3 of these nitrates here. So really, let's just tear this apart here for a moment. With this one, without this, let's do it without this first. There is 1 aluminum here. There's 1 nitrogen there, but we got times it by 3. This is like the distributive property. It includes everything in front of it that's inside of the parentheses. So that'd be 3 times 1, so that'd be 3 nitrogens. Okay, and then we got 3 times 3, so that is 9 oxygens. Then you go put this multiplier 2 in front of it. And now we've got to multiply everything times 2. So really now there's going to be 2 of those. 2 aluminums, because there's a 1 understood here. It's not times 3. Okay, and then there is 2 times 3 nitrogens, so there's going to be 6 of them. Okay, and then you can tell that there's going to be 18 of these, but let's double check that. You got 3 times 3 is 9, times 2 more is going to be 18 of them. So that's just helping you figure out how many of each individual element that there is in this equation. Now it is important when we balance a chemical equation, when we balance them, that we have the same number of of each element on both sides. So it's kind of like a teeter-totter here, and so if it gets too heavy on one side, that's not good. And so we need to keep on balancing it by placing coefficients in front. Now that should be a little bit of review from 9th grade science, but let's double check and make sure that we know what's going on here. Okay, so let's go ahead and look here. Now I like to do something that helps me be more successful at these, and I like noticing that, hey, I've got a nitrate over here and I've got a nitrate on this side. So you can really treat them like, since nothing changed them, you can treat them like they're a single element ion there. But so I like to notice I've got 2 nitrates here and 3 nitrates here. So it's just an idea to help you be more successful at these. Okay, let's go ahead and start. I always start with the first one just because, hey, it's right there. So I got 1 aluminum here and I got 1 aluminum here. Next I got 3 chlorines here. And so I'm going to check on the other side and I've got 2 chlorines. I need a common multiple, which is going to be 6 chlorines. Okay, so I need to have 6 chlorines. And this is just my thinking down below here. I need to have 6 chlorines. Oops. And so I'm going to go and put a coefficient of 3 because it multiplies everything after it until you hit another sign. Okay, so now I'm going to have 3 irons here and now 6 chlorines, just like what we wanted. Okay, so now I'm going to put a 2 in front of this one because I want a common multiple of 6 between these two. And so now I'm going to have 6 chlorines, and I also have 2 aluminums. Okay, well, before I had 1 aluminum, 1 aluminum. Well, that's okay. We'll just go to the other side and fix how many aluminums that there are. So here are 2 aluminums. And we're going to make 2 aluminums over here. Now notice that you've got this 2 multiplies everything until you hit that sign. So now there's 2 times 3 nitrates here. So there's going to be 6 nitrates. Okay, and so we've got 2 over here, but we need to make 6 nitrates over here too. Or I should say also. And so I'm going to multiply this one by 3. So now look at this. We've got 3 times 2 nitrates here for a total of 6. Now I've got 3 irons. And over here I've got 3 irons. Well, that's great. In fact, everything works out just groovy here, and it works out great. So let's answer some questions here. We had 2, 3, 3, 2. Okay, and so what are the names of the reactants here? Well, which side is it? The reactants are on this side. Okay, so what is this thing called? What do we call that in class? And I want you to write that down, and we're going to check on that when I return. And what did you call this guy right here for your other reactant? I should put an and here because you've got to fit both of these in there. Okay, so have those 2 names ready, and then of course the 2 names for the 2 products when I return. Okay, here they are. Here's your 2 products. There they are, the FeNO3. And don't forget that those irons need a what? Roman numeral. Okay, so we're going to go back down to one more side here. After balancing the equation, how many oxygen atoms are on each side of the yield sign? Well, let's go ahead and look here. We've got 2 times 3 is 6, times 3 more is 18 oxygens on that side. Let's double check on the other. No oxygens there. Here we go. 3 times 3 is 9, times 2 more is going to be 18. Okay. So what I want you to do before you see me the next time is I want you to go and do a couple of these, balancing these equations, just a couple, okay? And I want you to also come up with these 4 names up here, the 2 reactants and the 2 products, okay? Okay, so let's check to see how well you do, and I will see you here in a little bit. Bye-bye.